Elon, what kind of crazy dream would persuade you to think of trying to take on the auto industry and build an all-electric car?
Well, it goes back to when I was in university. I thought about what are the problems that are most likely to affect the future of the world or future of humanity. I think it's extremely important that we have sustainable transport and sustainable energy production. That sort of overall sustainable energy problem is the biggest problem that we have to solve this century. Independent of environmental concerns, in fact, even if producing CO2 is good for the environment, given that we're going to run out of hydrocarbons, we need to find some sustainable means of operating.
But most of American electricity comes from burning fossil fuels. How can an electric car that plugs into that electricity help?
Right. There's two elements to that answer. One is that even if you take the same source fuel and produce power at the power plant and use it to charge electric cars, you're still better off. So if you take, say, natural gas, which is the most prevalent hydrocarbon source fuel, if you burn that in a modern General Electric natural gas turbine, you'll get about 60% efficiency. If you put that same fuel in an internal combustion engine car, you get about 20% efficiency. And the reason is, in the stationary power plant, you can afford to have something that weighs a lot more, is voluminous, and you can take the waste heat and run a steam turbine and generate a secondary power source. So, in effect, even if you take in transmission losses into account and everything, even using the same source fuel, you're at least twice as better off charging an electric car than burning it at the power plant.
Okay. That scale delivers efficiency.
Yes, it does. And then the other point is we have to have sustainable means of power generation anyway, electricity generation. So given that we have to solve sustainable electricity generation, then it makes sense for us to have electric cars as the mode of transport. You have to come up with a really energy-efficient car. So that means making it incredibly light. And so what you're seeing here is the only all-aluminum body and chassis car made in North America. In fact, we applied a lot of rocket design techniques to make the car light despite having a very large battery pack. And then it also has the lowest drag coefficient of any car of its size. So as a result, the energy usage is very low, and it has the most advanced battery pack, and that's what gives it the range that's competitive. So you can actually have on the order of a 250-mile range.
I mean, those battery packs are incredibly heavy, but you think the math can still work out intelligently by combining light body, heavy battery, you can still gain spectacular efficiency.
Exactly. The rest of the car has to be very light to offset the mass of the pack, and then you have to have a low drag coefficient so that you have good highway range. In fact, customers of the Model S are sort of competing with each other to try to get the highest possible range. I think somebody recently got 420 miles out of a single charge.
Bruno Bowden, who's here, did that, broke the world record, 425. That was the good news. The bad news was that to do it, he had to drive at 18 miles an hour constant speed and got pulled over by the cops for going too slow.
Yeah, I mean, you can certainly drive, if you drive at sort of 65 miles an hour under normal conditions, 250 miles is a reasonable number.
Let's show that second video showing the Tesla in action on ice. Not at all a dig at the New York Times, this, by the way. What is the most surprising thing about the experience of driving the car?
In creating an electric car, the responsiveness of the car is really incredible. So we want to really have people feel as though they've almost got a mind meld with the car. So you just feel like you and the car are kind of one. And as you corner and accelerate, it just happens, like the car has ESP. You can do that with an electric car because of its responsiveness. You can't do that with a gasoline car. I think that's really a profound difference, and people only experience that when they have a test drive.
I mean, this is a beautiful but expensive car. Is there a roadmap where this becomes a mass-market vehicle?
Yeah, the goal of Tesla has always been to have a sort of a three-step process, where version 1 was an expensive car in low volume, version 2 is sort of medium price and medium volume, and then version 3 would be low price, high volume. So we're at step 2 at this point. So we had a $100,000 sports car, which was the Roadster. Then we've got the Model S, which starts at around $50,000. And our third generation car, which will hopefully be out in about 3 or 4 years, will be a $30,000 car. But whenever you've got really new technology, it generally takes about 3 major versions in order to make it a compelling mass market product. And so I think we're making progress in that direction, and I feel confident that we'll get there. The the goal of SpaceX is to try to advance rocket technology, and in particular to try to crack a problem that I think is vital for humanity to become a spacefaring civilization, which is to have a rapidly and fully reusable rocket.
Would humanity become a spacefaring civilization? So that was a dream of yours in a way from a young age, or like you've dreamed of Mars and beyond?
I did build rockets when I was a kid, but I didn't think I'd be involved in this. It was really more from the standpoint of what are the things that need to happen in order for the future to be an exciting and inspiring one. And I really think there's a fundamental difference if you sort of look into the future between a humanity that is a spacefaring civilization that's out there exploring the stars on multiple planets. And I think that's really exciting. And compared with one where we are forever confined to Earth until at some eventual extinction event.
So you've somehow slashed the cost of building a rocket by 75%, depending on how you calculate it. How on earth have you done that? NASA has been doing this for years. How have you done this?
Well, we've made significant advances in the technology of the airframe, the engines, the electronics, and the launch operation. I mean, there's a long list of innovations that we've come up with there that are a little difficult to communicate in this talk, but
not least because you could still get copied, right? I mean, you haven't patented this stuff. It's really interesting to me. You didn't patent because you think it's more dangerous to patent than not to patent.
Since our primary competitors are national governments, the enforceability of patents is questionable.
It's really interesting. But the big innovation is still ahead, and you're working on it now. Tell us about this.
Right. So the big innovation.
In fact, well, let's roll that video, and you can talk us through it. What's happening here?
Absolutely. So the thing about rockets is that they're all expendable. All rockets that fly today are fully expendable. The space shuttle was an attempt at a reusable rocket, but even the main tank of the space shuttle was thrown away every time. And the parts that were reusable took a 10,000-person group 9 months to refurbish for flight. So the space shuttle ended up costing $1 billion per flight. Obviously, that doesn't work very well for...
So what just happened there? We just saw something land?
That's right. So it's important that the rocket stages be able to come back, to be able to return to the launch site and be ready to launch again within a matter of hours.
Wow.
Yeah.
Reusable rockets.
Yes. And so